All right, hello there. I hope you're all doing very well today. So, today we have this rather simple script. I just show you around a bit how it works to have this rectangle which can be divided into several pieces. And then we have some buildings on top of that or shapes that get created when looking at them. You also have some kind of offset mechanic here as well that we can play with, and also kind of a division of the pieces as well. So we have different scenarios that can be done and created that way. So I will get you through the process one by one, so you know on which of the things we have to take care of. So I will just draw those things out for now. So the things that we want to do first. So I have a rectangle first here. Then this rectangle will be used to be as a base layer to create some streets that can be like defined like this. And then we also will create for the streets kind of a connection point that I will show you that wants to create those streets like together, like this more or less, where then we have different connection points, so it kind of like goes around all the time. So we have different streets on different places. Then once we have those streets defined, we want to create in the inner parts an offset, obviously with each of the things. And then we also need to take care, for example, in this case, the street might be too small. So if it's, for example, I don't know, like this is like if the x is smaller than, for example, 5 meters or foot or whatever you need to use, then this will be discarded. And then at the end, we basically just extrude them depending on the area. So with that in mind, let's get simply started. So let's create the rectangle first. So we have the rectangle, set one rectangle, define it here. Now we have the rectangle here. And the next thing is we define the streets that we want to use as the base thing. So I'm just going to create a couple of lines like that. So set one line, just do like several ones. Like we can do multiple lines like this. And another one. Be a bit random like this. You can also obviously create the lines in a different way. Now that we have the lines here created, we basically want to create this kind of revolving mechanic that we saw before, that we can go around the place and have different scenarios all the time. So I did it in the following way. Obviously there are different ways to do it, but here I just create the end point like this, create a polyline, and then actually close it like this here as well, setting this to true, and then do the same with the endpoints. And then I am creating like an evaluate curve command, so I can basically see how this point would look like. And here I need to reparameterize the curve. So I basically want this curve to start at this point all the time, right? I can do this by doing the shader command and using the curve parameters. I actually put this here as the base thing. And then I will be simply dividing the curve into several pieces like this, so that I have more control about the amount of like streets that I'm getting. So this will be then done also the same case with the other polyline that I create here, and also to reparameterize it as well. And now I'm able to put those two things together and create my own new lines. Let's see how this would like kind of look. Hopefully it will not be too messy. Okay. So now I have like my lines that kind of will get created around here, around this place. And obviously I might want to reduce the amount a little bit, and then I have like an effect like this. Yeah, which looks quite nice. Perfect. Obviously, I might want to make those lines bigger or the rectangle smaller. If I want to, for example, get this line more through, or I can obviously extend them maybe like a little bit if I'm choosing to do so. Perfect. Now that we have that, we want to take care of the basic surface. So we're going to use those lines here and then use the split surface command. And with that, we are using the base rectangle that we have here. And it automatically creates a surface. And we can also basically use any kind of, it can also be a circle or any kind of weird shape, as long as it's like on a planar surface. So if it's flattened, it should be like flat on the ground. It should be working rather well. So if I'm looking just at the output of it, I'm seeing already that I have some kind of surface happening here. And obviously, if I'm taking a look at this other command here, obviously those are always creating different places. So now that we have that, I want to basically graph this part. And I'm creating the offset curves that I'm creating here. And we're going to use a number slider, and we actually put an expression here to negative. So the curve will go negative. So now you already see certain problem here. So you have, for example, if I put this lower, this looks kind of fine, right? But then sometimes I have those really weird looking surfaces that I don't want, I can't really like use at all. So I want to fix those. So what are the two things in this case why those surfaces look as weird as that? Well, there is one. So basically, we can see if the curve is intersecting itself, or if the curve is not really on the surface it should be belonging to. So we will now create two expressions that will create a better, like a dispatch, let's say, in order for us to be able to know which one of those things can be used or not. So I'm going to use, first of all, I will take care if the surface is intersecting with itself or not. So I'm going to, well, here on intersect physical and then curve self. And I'm going to use this command here. And as you see, it will create, if the curve is intersecting, certain points like here. So I'm going to take a look at the list length of those amount of points. And if the list length is larger than 1, obviously, larger or equal to 1, I want to, or like, no, let's actually say it, like I want to have it smaller because I want to have it true. So if the curve is smaller than 1, the amount of points that are in the curve or that are intersecting within the curve are smaller than 1, then I want to have this piece of surface removed. So I'm going to use the dispatch mode here, and I'm actually using the param viewer in order to use the tree branch to remove those pieces of curve. So I use the tree branch here. I use the fragments that I have here in the beginning, or actually no, let me use let me use the offset curves already. And then we having our the same thing with the param viewer here. And now I want to remove certain objects from that list. So I'm going to use this part here. And with that, I'm having like certain trues and false values, right? And I'm going to use the tree branch here. Let me just quickly take a look at how I made it here exactly. So I'm not smaller than 1, dispatch pattern. Okay, I'm just doing this. Okay, so I can actually already put a, no, I have the dispatch pattern here with the booleans, and this will, so it will say like if those are intersecting, like intersecting booleans, And this will now give me if I take this basic list of the param of the tree that I want to remove those things from, and I use the intersecting booleans as the pattern, and I'm gonna flatten this one. So now it gives me two lists here, one with 2 values and one with 12 values. And if I use the list A, I'm getting just the values that I'm not intersecting with the curve. So I have this as the main layer. So if I'm making everything invisible, then you see, all right, cool. Now I only have the pieces which are not intersecting itself. Okay, that's pretty cool. Now, obviously there is another problem here. As you see here, this one works perfectly fine in a way, but it's offsets in all kind of weird directions. So with this part, I want to take a look if the outer points are on the surface itself that they should be belonging to. So we have our offset curve already, right? So we're going to simply explode this curve into several pieces, and then we can use the evaluate point on surface closest point command. Use this as the base surface, and then we use the vertices of the offset curve in order to see if they are on this or not. So now they probably all should be kind of like 0, 0, 0, but like obviously there are a few ones which are kind of like more than that. So I'm going to, what I'm going to do here now, I'm basically gonna just mass addition them together and see what the result would be. So now we have a few values that are kind of like 0, 0, 0, and a few that are like a little bit more than 0. So what I want them to be is like smaller, and now I could like say smaller or equal to 0, but it's a bit better if I say, okay, it's smaller or equal to a very, very, very small number, because, well, there are certain ways of defining 0, but then also a 0 can be almost 0, so I rather want to have it like rather to a smaller number. So that's how I would define it here now. And then I have the true and the false values here, and I'm connecting them together. So I have the values here, for example, in the dispatch pattern. If I'm just going to copy this here, and we name intersection, and here we name it point on surface booleans, and we put it in the dispatch pattern thing as well. And now the result should be, okay, cool, I have now this one removed. And those ones actually in a way as well, so that kind of like gets doubled. But what I want to do is basically have them work together. So I put those two just together like this in an AND gate, and this will then also work rather fine. Now, there is a third argument I want to take place as well, which is a simple, if it's bigger than a certain kind of size, then please take it. Let me just like take a look if there are like, for example, this one here, you see, that's like a rather really, really small curve. Let me just make the other ones visible. This one here is a rather really, really small curve, and I want this to be removed because it is just too small in order to be used as well. So we're going to use the same thing again. So we have the curve that is offset here, and we are going to use just the curved length command here, and then we just take a look if the length is smaller than, and let's say, for example, I don't know, between 1 and 10 or something, and we use it as another thing. So we can actually zoom in here and click plus, and then we're going to use small length boolean, and we use it as the last thing. Oh, and now you see it now just put the things that are just smaller than this. So we need to either we can turn it around by using like the invert thing here, but I think it might be better to just use a larger than command, because it is like more cleaner, let's say, to have it as a main thing here. And you see now that this little small thing gets already removed. Perfect. Now that we have that, we can also just like, if you go back to the base layer thing here, you see it's still creating those like very nice patterns that we wanted to have in the beginning already. But now I want to obviously also have them have some kind of like thickness or width or depth. And so we're going to use the extrude command. And we are simply going to extrude the curves according into the z direction. And we're gonna also use a boundary surface before that and have the base surface here. And then we're going to look at the area of that surface and use it as a base, kind of how big it is. And now you see, okay, this is like a little bit too much. So I'm going to click on the factor, right click, and then do the x divided by 10. And now, obviously you can have this in a different way. And now we have our nice surface here. So, and actually let's give this a little bit of a color. Something like a nice orange or something. Let's see. Perfect. I'll do a bit darker. Okay, perfect. Cool. Yeah, and then this is basically all that there's to it. And yeah, so I think this is like a really like powerful way of creating different scenarios of certain ideas that you quickly want to have, and you have those really nice kind of animations that go in there as well, I think, which can also be quite beautiful in its own sense for sure. So yeah, I think I'm actually gonna make an animation out of it as well, but this could be something for the next tutorial. So let me know what you think. I think this is a very useful file. I will also upload it to my GitHub account, and then you can take a look at and make this thing yourself. So have a great day, happy Grasshopper scripting, and see you in the next one.